Hello and welcome to the course Generative AI for Computer Vision. In this introductory lecture, we are going to cover different aspects of computer vision and generative AI. We start with computer vision, then we try to understand what are the generative AI tools and models for computer vision applications. Then we describe different challenges we are going to face for synthetic data generation. And we conclude our lectures by this application of generative AI for computer vision. In this course, there is two basic agenda. One is computer vision, another is generative AI. So first we start with what do we mean by computer vision. Now, when a human vision and understanding is explained or we understand that we see a particular picture by a human eye, then it creates some images in our brains analyze these images and then it interpret. Now for in this example, what we can see, this is an image, this is a color image, then we can interpret human is a picture of a human, then it's a lady, and finally we come up that is a famous painting called Mona Lisa. Now this interpretation of our brain by seeing an image, we understand that is done by a several level of abstraction or understanding. Now what is computer vision? What we have just said, it's a human cognition system. Now similar thing we want that a machine can do, a robot can do. So there is a camera here. This camera see this picture, or by this camera this picture is represented to a computing system or a robotic device which analyze and try the interpretation which is very likely, or we want that it supposed to interpret very likely as human interpretation at different level of abstraction, such as color, image, human, lady, and so on. So as a whole, the basic understanding of computer vision is that seeing an image or video, can we interpret this image or video at different level of abstraction like our human brain do. Now next thing, what we try to understand, what is generative AI, what does this mean, and why it is important for this computer vision task. Now generative AI is a subset of artificial intelligences or AI that creates new and original content. Now this is very important, that in general what AI is to, that it's a rule based system. It follows some rules, they create an intelligent base or knowledge base or intelligent based, and it do their jobs, prediction, etc. Now rather in this Gen AI or generative AI is a subset of AI that creates a new or original content. For example, it can create text, it can create images, code, audio, video, and so on. So, how? By learning patterns from a large amount of existing data. So, generative AI basically has a power to create new content like text, image, code, audio. So, it has a capability that its foundational models, or it has a capability to generate a human-like content and solve problems, respond to user prompts. So this kind of capability or specialty this generative AI has. Now if we see the core technologies or the foundational models of generative AI, we will come across different very famous models like generative adversarial networks, popularly known as GANs, variational autoencoders, VAEs, and based on these models, some transformer models, large language models, diffusion models, etc., which enable the creation of realistic and contextual relevant outputs. Now, generative modeling, if you go bit a slightly bit technical, it's an unsupervised learning task. We'll come later details about generative modeling, and it learns the patterns of input data from a given distribution. So distribution is given, and these models, whatever we have said, they try to understand or model the pattern of this input data from this given distribution. The distribution may not be known. The distribution is given by a set of samples, okay? Set of images, a text corpus, like that. What is the purpose? To generate new examples, which belongs to the similar distribution. But one thing we have to remember, this similar that belongs to similar distribution, but it is not similar that is available as input data. It is not regenerate or reconstruct the input data, but it's a input data like images or text or any modality data which has a similar distribution of the input or given distribution. Okay. Now, why generative AI is becoming very important in today's world? If we observe in the recent literature, we can find that deep learning has achieved a significant success in supervised classification. In this figure is basically results from ImageNet challenge, and we can see the accuracy or top 5 error has been substantially decreased, reduced by means of different deep learning models. For example, in 2012 AlexNet, after that, and 2014 VGG or GoogleNet, 2015 ResNet, and so on. And you also can see that ResNet can beat the human accuracy also. So what we understand from this, that this deep learning now becoming very important for computer vision task and many other fields like NLP, medical imaging, neuroscience, and so on. Now, what the problems with this kind of models? deep models. In general, these deep models are supervised in nature. So these models requires large volumes of accurately annotated data for this kind of supervised learning. So what is the major issue here? That the model performance is basically depends the size, quality and diversity of the annotated data set. And if it is increased, definitely the model performance increase. But then what is the problem? The problem is collecting and accurately labeling such large data set is very expensive. Not only that, it is also time consuming and often very much impractical. For very there's a lot of real world application like medical imaging or underwater exploration, remote sensing, some and etc. So different applications. Now we can understand very easily that in medical imaging, human annotation is very costly because it's required some radiologist or some medical practitioner to be involved to accurately label. Otherwise, there is a chance of a severe problems of model or modeling this data. Similarly, some in underwater exploration, some images, getting these images is very tough. It's very rare, very few examples, images or videos for a particular type of fish or any underwater creatures. So these are the basic problems of getting a large data set or large annotated data sets, which is very much required for these deep learning models. So what is the solution for this problem? If we can synthetically generate the data, what is powered by these generative AI models, then it solves this kind of problems. So it is an emerging solution of as it can create a realistic level data set at scale, and definitely it's a very accurate also. So this generative AI based synthetic data generation reduce the dependence on mutual or manual data collection and annotation while improving model training and performance. Okay. So generative AI for computer vision become one of the major research areas both in academic and industry at this point of time. So generative AI for computer vision is a rapidly advancing field. A lot of research is going on and different tools, different mechanisms are being invented for this particular topic. So it's now becoming happening on this area of artificial intelligence. Now, what exactly we are doing here? As we know that in computer vision previously, we are analyzing the visual data to predict something. But here we'll extend this work to create new images, videos or visual content. So that is the one of the major aspect of generative AI for computer vision. Now, if we see the literature, we can see there is a different deep learning models such as generative adversarial network, variational autoencoder, diffusion models. These models are being used as a generative AI tools to generate realistic image, enhanced image quality. That means if image quality is not up to the mark, maybe noisy, let's say for example, it's a hazy image, or there is some noise, maybe kind of communication noise, some underwater image. These are mostly noise due to different underwater lighting conditions. To enhance this kind of images, these generative models are very well performed. Another important is image to image translation. That means that there is a, say, a gray image, grayscale image, we can transform it to the or translate it to the color image, and there is some sort of inpainting kind of and fill in missing visual information kind of, or there is some distortion in image or video. Can we that recover that part? So in computer vision application, this generative AI are mainly used for this tasks such as data augmentation, image synthesis, super resolution, object generation, medical image reconstruction, and so on. So these applications will see in this course that how these models like GAN, VAE, diffusion models, transformers, these models are how these models are to do this or is applied in this application like this data augmentation, that's image synthesis, that means creating new image, synthesizing new image, super resolution, object generation, medical image reconstruction, and so on. So as a whole, that these are the generative AI is used for this computer vision task. Now, this creating high quality synthetic data, that AI helps to improve the accuracy and robustness of the vision system. Now, what we have understood in previous few slides, that for a robust and accurate deep learning model, we require label data, which is costly, which is time consuming, and sometimes it is very tough to get that kind of images. Exactly here, generative AI play the crucial role. They artificially synthetic image, they artificially prepare the synthetic image, generate the synthetic image, so that a large label data set may not that much needed, that this synthetic data can replace this. So definitely to fill in this gap, this generative AI, that these capabilities of generative AI, mainly in computer vision, transform the industry like healthcare, autonomous driving, entertainment, and surveillance, where this kind of supervised deep learning is very important, and there is data scarcity of annotated data scarcity, and this there This generative AI are being used vividly to generate the synthetic images to fill the gap. Now, before we go to understand different techniques and go to the deep in this topic, first you understand what are the major challenges. In this course, we face or will get back again this challenge in different discussion. So as the introductory lecture, we try to understand what are the major challenges we will going to face for synthetic data generation. First of all, it is a challenging task because that how this data, what data we are basically generating, it should be very much realistic, like a normal data. It looks like a normal data. It's not so easy task. First of all, first challenge, achieving the high visual fidelity. So visual quality of the image. There is a different parameters of this synthetic data. Just for example, it should not be very noisy, or it should not look like it is a AI generated. It look like a very normal and with high visual fidelity while preserving fine details, texture and natural lighting conditions. So these are the major thing. It's not so easy to maintaining these properties of the natural images when generating these synthetic images. These models, what we are going to use here, like generative adversarial network, transformers, diffusion models, variational autoencodes, and such, they should not produce the artifacts, distortion, or unrealistic feature that reduce the image quality. That is another important challenge. We'll understand this. These are the very kind of superficial discussion, okay? Some naive way to discuss. Then we'll go in this course in a very in-depth understanding, technical understanding of what is the meaning of this and what exactly the problem we face and how we going to solve this. Another important thing, the ensuring diversity, that if we generate the data synthetic, let's say we are generating some synthetic data of some flower. Now one thing we can see or we can observe that sometimes these kind of generative models generate a very similar kind of images. Here the flowers. So there is a level of diversity is less, and that is one of the major difficulty. And these difficulties is basically known as mode collapse. So this model generate limited variation outputs. So how to solve this? So that we are generating the data or images that definitely follow a distribution, but there should be some diversity among the generated images. That is one of the major challenges. Other things in this line of thought or in these challenges, the consistency in complex scenes. Just for example, for understand, if you basically generate some video there should be an object relationship in temporal relationship. How an object is being moving in a subsequent frames. In other ways, say for image also, there should be some sort of consistency among foreground object and background objects. There is some contextual relation should be maintained. So the object should have some consistency on backgrounds and perspectives, and that is also very challenging. It should not be that one cow is basically standing on a tree. It should not be like this. So that contextual consistency is very important when we generating the data or images. Basically, when creating a synthetic image, that should be like that it represents real world data without introducing some bias, and requires that on a large and diverse training data set. That means when we giving a generative model, what actually generative model doing? It taken as input a real distribution, a real world data. Okay, and with this distribution, they try to generate some data. This data is basically should belong to very close to this given distribution. So if we have to represent or we have to generate the real world data without introducing the bias, it requires a large and diverse training data set. That is also a challenging task. And finally, there is a high computational cost, extensive training time, because these models are in general very deep model. So computational cost, this training time is very high. Another very important thing that we have to be very much concerned about ethical misuse, such as there is some topics or some models like deepfakes that can be used in a very negative way. It can be used for some illegal things. So this kind of information, rather we should say misinformation, that we can create some video that is basically fake video, and that is one of the major issue nowadays, that using this kind of generative models we easily design some fake videos, and definitely some legal issues will come, some other socio-economic issues will come, so that will be a very much concern about that. So this kind of issues further complicate the development and deployment of realistic image generation systems, and that is very important and challenge of synthetic data generation. Now, what are the major application of generative AI for vision? Definitely there is a across the different industry, from healthcare to entertainment to tourism to kind of sports and so on, remote sensing. There is a lot of different industries or technologies where this generative AI is a numerous application in computer vision. So as we said, it is widely used for image synthesis, enabling the creation of realistic images from text description or existing visual inputs. Nowadays, it's also possible, given a radiological image like X-ray or MRI, can we generate the report automatically? So that is from image to text generation. That is what one of the important aspects. This is a bit multimodal. Both image or video and text modalities are involved. So in healthcare, generative model assisted medical image reconstruction, enhancement, and the generation of synthetic medical data for training diagnostic systems. That is also a very important field because medical image or medical imaging systems are very sensitive because it's cause life death situations. So we have to be very careful what data we are synthesizing, what data we are generating. It should maintain or it should be very much realistic. And the corresponding annotation should be very much close to the actual annotation. So these are the one of the major application areas of medical imaging. Then another thing, enhancement. Enhancement means there is nowadays lot of different medical equipments. Let's say X-ray, that is portable X-ray devices. The output of the portable X-ray is not up to the mark as the real X-ray. So can it be possible to enhance from this input to the output? And generation of synthetic medical data, as we said earlier also, for training diagnostic system or different kind of predictive or assistive systems. Now, definitely where there is a data scarcity, data augmentation is another important application where artificial images are created to improve the performance and robustness of the computer vision models. That we said that these computer vision models are deep models nowadays in supervised paradigm. So we need a lot many data for to get a robust vision models. And if we generate this synthetic data, this data augmentation will become very much useful for this particular applications. Apart from that, generative AI is also used for image restoration. That is, we have said already then that the application like underwater exploration. In underwater, there is a lot of noise because there the light is basically these different lighting conditions are there. So there is and in underwater there is a different kind of image degradation happening. So the task like super resolution, denoising, colorizing, inpainting, these are not only in underwater exploration but other domains like medical imaging, this remote sensing and such is very important, where generative AI playing a very important role. In the entertainment and gaming industry, this now it's becoming a big industry now. So this kind of VFX design This generative AI helps this realistic character, environment and visual effects. So that is also another very big application areas where generative AI can play a big role. Okay. Next coming the autonomous vehicles, where synthetic data generation is required to train a perception system under diverse driving. The question is, when there is a robotic agent like autonomous vehicles, that these vehicles should be trained with a huge practical data, and these data, collecting this data is always a very costly affair. So if we train or if we generate this practical data synthetically by means of the generative AI, then it will be a very useful. Additionally, applications such as facial recognition improvement, virtual try-on system, content creation, digital twin development demonstrate the growing impact of generative AI in computer vision. So you can say face recognition, visual try-on system, digital twin development, that is also very important. There is a system that is a, let's say this electromechanical system. Can we simulate or can we do kind of digital twin of this kind of system? That's called digital twin. That also a generative AI very much helpful. So in summary, in this particular introductory lecture, we first understand what is computer vision and generative AI. Then we try to understand how generative AI are used for computer vision. What are the main challenges we face for synthetic data generation and different application of generative AI for vision. In next part, we going to understand what is the basic difference between discriminative and generative learning. Thank you very much.